going to be comparing numbers. So we're going to see two numbers in scientific notation with a box in the middle. And in that box, we're either going to fill in with a sign that looks like this, a sign that looks like that, or a sign that looks like that. Okay, it's like a multiple choice question with only three options. What does this first sign tell me? Greater than or more than? That's right, the alligator with the opening the mouth to the bigger number. What is this one? Less than? What's the last one? Equal. Pretty obvious when the two numbers are equal. We're not even going to talk about that really. There's a couple things to consider when we're comparing size of scientific notation numbers, right? Every number in the, yeah.
How you know, on the problem there, like if you put like the thing, like greater than, couldn't you put the other one and the other one's just greater than 2?
Yeah, that's a good question. I'm glad you pointed that out. So just like when we're reading a sentence, we read from left to right. So if I had a number over here, I would say 10 is greater than 4. You know what I mean?
Oh, yeah, I get it.
Yeah, I wouldn't say 10 is greater than 4 and read from right to left. So we're always reading left to right. That people do wonder that, and it's a valid question. Just think from left to right? So here I've got this one's on the left, this one's on the right. This one is either greater than 7.1 or less than 7.1. We got to figure it out. So if you look at this, right? We got to look. First thing we want to look at is the exponents. So first compare the exponents. Then we're going to compare the leading numbers. Because all my leading numbers in every single one of these problems is going to be in between 1 and 10. But some of those numbers, when we expand them out, are like 40 million, and some of those numbers are 0.00002. Okay? So the first thing I need to do is compare the powers. If the powers are different, then the leading number doesn't even matter. So let's look at this first example. Example 1. What are my exponents here in example 1? 6 and 6. Are those exponents different or the same? They're the same. So because the exponents are the same, the number with the larger leading number is the bigger number. Okay, is my bigger number on the left or on the right? Well, what are my leading numbers here?
Right.
I got 4.6 and I've got 7.1. Well, which of those is bigger, 4.6 or 7.1? 7.1. So 4.6 times 10 to the 6th is less than 7.1 times 10 to the 6th, right? Reading left to right, just like that. Give me a thumbs up if that makes sense so far, right? If we expanded these out, we would see that this one is like 710,000 and this one is 460,000. Obviously, 710,000 will be more. This is only if the exponents are the same. If the exponents are different, like I said, the leading number doesn't matter. What are my exponents in example 2? What are my powers?
3 and 2.
I got 3 and 2. So because the exponents are different, the number with the larger exponent is the bigger number. Which number has the higher exponent, the left or the right? The left. So 8.0 times 10 to the third is greater than 9.9 times 10 to the second. Here's why this can be confusing, right? Let's ignore the powers for a second. Look at my leading numbers. Which one is bigger, 8 or 9.9? 9.9. So how can a number that's bigger actually be less than? Well, that's because of the power, right? If I expand it out, 8.0 times 10 to the third, 1, 2, 3, that would be 8,000. Right? If I expanded out 9.9 times 10 to the second, what would that be equal to? 990, because I'm only moving the decimal 2 spaces. Well, now that we've converted them, it's pretty obvious which one is larger, right? So these little tricks that we're talking about in the notes are just shortcuts so that we don't have to expand something out, especially if it's like 6.4 times 10 to the 25th. I'm not writing out 25 decimal places. I don't have time for all that. So these are like the little shortcuts. If my power is bigger, that one's bigger. If my powers are the same, then I compare the leading numbers. That sound okay? It's pretty straightforward, right? Let's look at example 3. Are my exponents the same in example 3? No. What is the same though? The leading numbers are the same. So just because the leading numbers are the same, it does not mean these two numbers are equal. Right? If we're in a rush, we'll look at this and go, oh, 2.4, 2.4, those are equal to each other. But they're not. My powers are different. Here's another thing we have to think about. If I have a negative exponent, is negative 4 a bigger number or is negative 2 a bigger number? Negative 2 is the bigger number. Right? If I look on a number line, whichever number is furthest to the right is the bigger number. Well, that would be negative 2. So am I going to put in a greater than sign here or a less than sign? Greater than?
Less than.
Less than. 2.4 times 10 to the negative 4 is less than 2.4 times 10 to the negative 2. Let's expand these ones out. Just to see. If I expand out the left side, 2.4 times 10 to the negative 4, I'm going to move this decimal 4 spaces to the left or to the right? To the left. I want my zeros in the front. Small number. 1, 2, 3, 4. 0.00024. Very small number. What about this one? How many spaces am I going to move this one to the left? 2. 0.024. Well, when I look at it like this, obviously this one is the bigger number. They're both still really small numbers, but if I'm comparing them, one has to be bigger, one has to be smaller. Otherwise, they would be equal. These two numbers are not equal. This one is much bigger. All right? Quick show of thumbs. How much sense is this making? Thumbs up makes total sense. Thumbs sideways makes a little bit of sense. Okay, cool. Take 60 seconds. Fill in the 3 blanks down below. Example 4, 5, 6. I'm going to combine and see what we get, and then we'll do them together. Look at the exponent first. The exponents are the same. Then we defer to the leading numbers. All right? Yeah, right. Check that last one real quick. See if you can figure out what's wrong with it. Good. Yes. I got you. Good on the first one, Matt. What about the second one? Okay. What makes you say that? If the exponent's negative, my zeros are going to be in front. If it's positive, yeah. If it's a positive exponent, that's a big number. I'm going to bring this decimal 2 spaces. When you see it, you're going to...
You got a lot of the edge.
Expand both out. See
Oh, what? Edges. You said I had edges.
Yeah, Ray is going to go and then you go.
You said I had
Yeah, you're good there. Those are right. You can go.
what? These edges.
Good, right? Yeah.
Will we leave 8th grade? Will we be happy?
No, I don't think so.
Nah, me, because I was a student of mine.
Yeah,
Why
he
good
is.
student?
He's not lying.
Congratulations.
No, I will not be happy you guys are gone. I'll miss you guys. All right. Let's take a look. Example 4. Are my exponents the same? No, they're not. So the leading numbers don't matter. Which exponent is bigger, -6 or -7? -6. Greater than symbol goes in there. Are my powers different or the same in example 5?
Same.
They're the same. Okay, if they're the same, we'll look to the leading numbers. Which one has a bigger leading number?
They're the same.
They're the same.
Equal.
So it's equal. Right? They're the same number. It's the same exact thing on the left and right. Obviously, it's going to be equal, right? And Al, is that what you got for number 5?
Yeah.
Okay, cool. Number 6, are my powers the same?
Greater than.
What?
Greater than.
Greater than? Okay, good. Are my are my exponents the same on number 6? No, right? One's 5, one's 4. Which one's bigger, the 5 or the 4? 5. So I'm going to throw in a greater than, right? So it's real easy. That's why the homework is like 30 questions, because it takes like 2 seconds each problem. So I don't anticipate it taking a whole lot of time.